Hello, welcome to a brand new episode on explanation of the per unit system. So, as far as the single line diagram in the yesterday's class, what you have seen regarding the single line diagram. So, today's class we'll be understanding the per unit system. So, as you can see, the per unit system is in front of you. Basically, what per unit system means is that we have different currencies. Like in power system, we have different values of voltages, currents, impedance. So, we may want to make them to a one single base. So in order to get them to a one single base so that our calculations part becomes easy, so that is the reason why the per unit system, like power transmission lines, are operated at different voltage levels. They are in the kilovolt is the most convenient to express the voltage, and we have kilovolt amperes, megavolt amperes, kilowatt or megawatts, and amps and ohms are expressed as percent or per unit value. So the basically what is the reason the per unit method, as far as in concern to the percentage method, has an advantage because per unit value is expressed in per unit itself, but the product of two quantities, if you do in percent, must be divided by 100 to obtain the result in percent. So that is the thing. So for example, zero point 0.9 into zero point 0.9 or 90 into 90, so you get product. But as far as the per unit value is concerned, we need not require to deal with it. So now we will be understanding basically what a per unit system is and how it is done. So suppose what I take per unit, let's take it to a base value. Let's take explain it to you in a more convenient manner. Let's suppose it's a financial transaction. So you are having it in different currencies are there. Dollar is there, yen is there, taka is there, real is there, dirham is there. And so suppose you are taking nowadays, like suppose like dollars value is equal to rupees 70. So the actual value you are taking, so per unit is basically your actual value, whatever the actual value you have taken, divided by the base value. So divided by the base value. So base value is dollar in this case, actual value is rupees. So rupees 70 divided by rupees 70 is 1 per unit in case your actual value is 70 rupees. Now if you are taken 140 rupees, then your per unit value be 2 per unit. Now in case of voltages, let's suppose we have 120, 126, okay, and we have 100 volts, 108 volt, okay. Now let's suppose we, out of these all the values, we have taken one particular base, okay. So that base is, let's suppose, 120. If you have taken, so the actual value of the quantity 120, 120, so this is 1 per unit, okay. Now when you have taken the base, so that means base value will get divided over here. So this is around 1.05. Here 108 divided by 120, so this is around 0.9. So this is the value in the per unit system. Now in the power systems, let's move to the next slide and let's understand the power systems. How does it operate and what are the parameters that are essential in a power system? As far as the power systems are concerned, so we will notice that there is these quantities: voltage, second quantity uh, current, okay, third quantity would be product of voltage into current, fourth quantity you voltage divided by current. So this product of voltage into current, okay, this gives you the VA. This V by I gives you the impedance. So this is your impedance, okay, and this value is also your S value, that is your complex power. So basically, when we are studying the impedance, this per unit system, so I already explained you what is per unit. So any quantity, if you have to explain that quantity in terms of per unit, so what you have to do per unit, it would be Z actual, the value of actual, Z actual by Z base. This is it. So what is your like if you have to operate the per unit system, so you can write basically in the per unit system what happens in the power system. Your voltage is normally taken in KVA, taken in kV, and current in amps. Current in amps. One more important point. See, if you are taking a single phase system, if you are taking, you can see phase to neutral. So the voltage would be between, if the phase is line, so V line to neutral. So you have to take in a single phase system, V line to neutral voltage is considered. Okay, is considered in case of a three-phase system. In case of a three-phase system, if you notice the three-phase system, so you'll be noticing that if you notice the three-phase system, let's so it has a line and a neutral. So you cannot take, you have to take the line to line if it's a delta, or in the delta also you say line to line, line to line. So V line to line voltage is considered, is considered. Again, one more important point is that power in three phase would be V phase, I phase. Now if you have to express it in line, so suppose you have taken the star connection. In star connection, your V phase is equal to V line divided by root 3, whereas your I phase is equal to I line. So here you the voltage would be root 3, power would be root 3 V line, I line. Suppose you are taken in delta. Now in delta, what would be the scenario? In delta, your V phase would be equal to V line, but your I phase would be I line by root 3. So again the same thing, root 3 V line, I line. So this is very important concept as far as the per unit. Now let's move back to the per unit value. So we have the third point over here to understand is we have the per unit value, that is our base current. So I write my base current in amps, and I express this in terms of base KVA, base KVA, single phase. Now let's consider the single phase system, and base voltage. Okay, base voltage, the voltage anyhow by default would be in kilovolt line to neutral. Okay, because I have taken voltage is normally taken in kV. Okay, so this is one thing. Now the fourth thing over there is that base current I have taken, base impedance I'll write, base impedance, that is my Z base, base impedance, that is Z base. This would be equal to V base. Okay, base voltage VLN divided by base current in amps, base current in amps. So now we have this thing, so I can substitute my value over here from the equation 3 to equation 4, and I'll get an equation Z base. I can write now my base voltage VLN divided by, so this is my base voltage VLN divided by this. So base KVA single phase, base KVA single phase into your base voltage KVLN, base voltage KVLN. Now if I look at this point, so let me rub here because this was just for the explanation purpose. So if I'm rubbing this point, so you'll be noticing, okay, let me write, I've rubbed this point, and yeah, so Z base I've written in terms of this quantity, so I can express this Z base in terms of base voltage, that is voltage VLN whole square, and one K term will come out. That K term can be written as 1000 divided by base KVA single phase. Now one more thing you have noticed in the very beginning, I told VLN would be always taken in terms of KV. So base voltage, I can, instead of VLN, I can write KVLN whole square into 1000, okay, divided by base KVA single phase. Now if I multiply this by 1000, okay, or what I can do is that if I have to resubstitute this K, this is base VLN, so I'll multiply this by 1000 and 1000, so this thing will not be there, 1000 and 1000. Wait one second. So I can write this K, I can take into 1000 into 1000, so this can be base, this can be base MVA single phase. So either you can write like this or like this. So this was about the single phase system. Now let's go for the three phase system. As far as the three phase system is concerned, the same thing you will do. So your base current would be equal to, now here in the case of three phase, base current would be equal to base KVA three phase divided by root 3 into base voltage, because now you are taking the line voltage and you have to express KVLL, and your base impedance in case of three phase would be equal to base voltage line to line divided by root 3 into base current. Let this be equation 1, 2, and from this base impedance you'll get, how much you'll get base impedance, you can substitute base VLL divided by root 3 into root 3 into base voltage VLL into K, that K factor is there, and this is base current in KVA, base KVA three phase. So this goes again, you are left with the same expression, base VLL V line to line whole square into 1000 divided by your base KVA three phase. If you multiply with 1000, so it will become your base KVLL का whole square into base MVA three phase. So now you have understood how these things are coming. Now if you have noticed, your Z base is equal to here, so this Z base is equal to, so in the next slide we'll be writing, so our Z base we noticed is nothing but it is equal to our base KVLL का whole square into or base VLL का whole square. You can express this in terms of because V, okay, divided by base KVA three phase. Okay, so this can be, or so this is, if a K you have to insert over here K square, so this 1000 will go, so this can be written as MVA three phase. So this is like I'll be rubbing over here, so that, yeah, so this is, I've rubbed here, so we can write base KVL and base MVA. So this is base, if you are writing like this, MVA. Okay, so Z base is like this. So Z per unit is what? Z actual by Z given. Okay, suppose you want to calculate a new per unit, okay, based upon the Z old. So what you have to do is that first you have to write Z given, okay, and Z new. So if you notice the Z given, so Z given would be base KVLL given whole square divided by base MVA given, okay, and Z new would be base KVLL new का whole square divided by base MVA new. Now what is this? It is Z actual by Z given, Z old into Z actual by Z given. So Z actual was what? Now here Z actual by Z given you have to write in terms of this. So you first thing is that your Z actual is your this quantity, okay, and now the new is this quantity. So you have to write Z old into base KV given, base KV given का square into base MVA into base MVA given, now divided by this term, in multiply, this term will come up, this term will come, no, this would be base MVA new divided by base KVLL new का whole square. Now you can separate these two terms and you can write this Z per unit new is equal to Z old into, you can separate this base KV given divided by this square and this square, this combination base KV LL. So this is also LL, okay, LL, okay, new whole square into base MVA new divided by base MVA given. So it can be either MVA or KVA. So it depends what type of power system you are using. So this is the most important formula over here. So let's try to solve one problem. Okay. Let me try to solve one problem. So, so that you'll be very confident after this. So let's try to solve a problem. Okay. Single phase star connected. Okay, it is given a single phase star connected load is drawing power at a voltage of 0.9 per unit and zero point 0.8 power factor lagging. Okay, the three phase okay, the three phase base power and base current are base power and base current are 100 MVA. So is given the base, that is 100 MVA, and the current also is given 437.8 amps respectively. Okay, so respectively the line to line load voltage is in the, now you have to calculate the line to line load voltage in kV. Now in order to calculate the line to line voltage in kV, how do you do is that, so the number one thing that you will notice here is your voltage is given, voltage is equal to 0.9 per unit. Okay, your power factor is given, so write the given data, read the question once twice before inking it, and your S base, that is your MVA 100 MVA. Your I base is also given, I base is given as 437.38. Okay, 437.38, sorry, this is 38 amps. So now for a three phase star connected, now I told you for a star connected or for anything, so you'll write root 3 VB LL IB. So this is your complex power. So if you have to calculate your this your VB line to line, so you have to calculate your VB line to line. So S base is 100 MVA in 10 power 6. Your I base is given, this root 3 will come down and you will calculate 437.38, or once you solve it, it will come around VB line to line gets around 132 kV. Now what is this VB line to line? So notice that what is the base voltage value. Okay, so the base voltage value over here, so he has given the per unit value, so voltage per unit value he has given 0.9. So that means 0.9 is equal to V actual by V base. Okay, V actual by V base. So here what you calculated, your V base, you need to calculate V actual. So V actual would be equal to 0.9 into your V base. V base is 132. So once you calculate it, you will get a value of around 118.8 kV. So this is how the problems on per unit system are calculated. Now if we move to another problem, very simple problem on per unit system. So let's do one more problem. These are the competitive exam problems. So let's do one more problem and make our skills strong as far as the per unit system is concerned. So problem number 2, let's do it. Let's write in a three phase, in a three phase, okay, 5 kV 5 MVA system now is asking what is the base impedance, what is the base impedance. So already by now most of you might have done this problem, so it's a very simple problem. So how you'll do it? So as you know that your Z base is basically what? Z base is nothing but we have calculated kV square by MVA. So kV square, it's giving 5 kV, so 5 in square, okay, and kV also you have to consider, that is 10 power 6, and your MVA, that is 5 into 10 power 6. So this cancels, so I think 5 would be the answer. Yeah, so Z base is equal to 5 ohms. So another question like this, you have to understand how you how you are doing questions. Like one more question, let me take one more question, okay, so that you will become more confident in the per unit systems. Okay, let me take one more question, question number 2, 3. For a given base voltage, okay, for a given, so you have this formula, okay, Z base you remember is nothing but kV square divided by MVA, okay. Sometimes you have this also, kV square, okay, into 1000 by KVA. Some books are writing this also. What they are doing is that V line to line square I did, into 1000 I did, by KVA I did. What they are doing is that they are writing V line to line in terms of kV. So basically the line to line voltage would be like 11 kV. So that V line to line they are substituting, that's why they are writing this like that they are doing. Okay, so this was one explanation. So for a given, base voltage, let's see, base voltage, for a given base voltage and base volt amp, volt amp the per unit impedance, the per unit impedance value of an element is X. Value of an element is X. So this is one thing. What will be the per unit impedance? So it's asking what will be the per unit impedance, what would be the per unit impedance value of an element, value of an element when the voltage and volt ampere, when the voltage and volt ampere value are doubled. So this is the basic formula that I have shown you. So in the basic formula you will substitute the values. So basically you know the formula, Z per unit new is equal to Z per unit old into Z per unit, sorry, happen, okay, some circle, okay, Z per unit old, okay, so into what, into MVA, new divided by your MVA old into KV old square by KV new. So KV value, this would be this also square, okay, the whole term comes under square. So what it does is that it is trying to double the value of the MVA value. The old value is getting doubled, okay. So the old value you have to double there, and the new value you have to see though. So the earlier value was X. So this value was X. So your what it does is, what will be the per unit impedance value of when the voltage and volt ampere value are doubled. Okay, so the new value, okay, is doubled. So the new value is double of the old value. So you will write twice the old value. Okay, this would be, this twice MVA old would be equal to new. This is MVA. So this will cancel. Okay, same denomination. And here also you have this KV old, and new value will be 2 times the KV old value. So these two values cancel, and finally you have X into 2. Oh, okay, and 1 by 2 ka whole square into 1 by 2 whole square. So this is X 2 by 4. So this two ones are, this is 0.5x. So this is 0.5x. Hope you have enjoyed the lecture. Please, for getting more understanding of the subject, please like, share and subscribe to this channel. And we'll meet next time with a new lecture, with a new concept. Thank you very much for your support and love. Thank you.